Good day, students. Today we will talk about Introduction to Mensuration. Let's start with this line. There are blank kinds of people, those who understand binary and those who don't. By the way, this is a copied line from the internet. So is the underlined number 10 or 2? We will find out later. First, let us define what is mensuration. According to Merriam-Webster, mensuration is a geometry applied to the computation of lengths, areas, or volumes from given dimensions or angles. Simply put, it is the act of measuring. In computing, such act will not require the use of specific measuring tools. It instead uses virtual measurements to refer to different measurable specifications of various computer components and converting between the different number systems used in computing. Remember, computer can only understand zeros and ones. They are called binary digits. Also, you have to take note that bits are the smallest unit of information that a computer supports. Let's now talk about binary and decimal. First, what are binary digits? Or what is a binary digit? It is the simplest kind of number system that uses only two digits of 0 and 1. Correct me, class. Let me correct myself. We are now talking about binary number system. Again, it is the simplest kind of number system that uses only two digits of 0 and 1. It is considered as computer machine language. Also, it is the only recognizable data to the computer. Take note that the computer can only understand machine language, which is made up of ones and zeros. The binary simulates the toggle switches that a computer uses to perform its calculations. And always take note that a binary digit has a base or radix of 2. Now let's talk about decimal. It is most familiar number system to the general public. If binary's radix is 2, the base of decimal is 10, which has only 10 symbols, numbers 0 to 9. Again, decimal number system has a base or radix of 10. Let's now move on to the next topic. This is about conversion from binary to decimal number system. There are two ways to convert a binary number to a decimal number. First is using positional notation. Second is using doubling. Let us first look at the examples of the conversion from decimal to binary. As I asked you earlier, there are 1-0 types of people, those who understand binary and those who don't. If you are able to understand binary, you know that 1-0 is equivalent to 2 when converted to decimal. Therefore, the line says or is read as there are two kinds of people, those who understand binary and those who don't. Now let's talk about the first method of converting a binary number to a decimal number using positional notation. So this is how it works. I will now convert 1000 1100. Why do we have a base or radix 2 here? This is constant if we will talk about binary numbers. Now class, how do we solve it using positional notation? Here's how we do it. You have to count how many digits your binary has. Let's do the counting. I have here 1, 2, 3, 4, 5, 6, 7, 8. In this case, I have 8 binary digits. Since you have 8 binary digits and your base is 2, first you will write down 8 number 2's. So let's check our table. I have here 1, 2, 3, 4, 5, 6, 7, 8. Just disregard the exponent first. So I have now here a set of 8 digits which are actually, or which have the same base, which is 2. Now, how do I work on the notation? Always take note that for the exponent, it always starts with 0. So we have actually, or we already understood that we need 8 twos first. Then we put the exponent, and we always start with 0, and we start from the right to left. So I have here 0, 1, 2, 3, 4, 5, 6, 7. Now what do we do next? The next thing that we do is below it, we convert the exponents, or the base and the exponents. But if you find it hard, here's the tip. You always start with 1 in the conversion, then to get the next answers, you always multiply it by 2. For example, again, we always start with 1. You can convert this if you want to, but if you find it hard to convert these numbers, then you can always start with 1. Anyway, you will just get the same answer. Say I have here 1, 1 times 2. I have 2 here, 2 times 2 is 4. That's why I have 4 here. Next, 4 times 4, 4 times 2. 4 times 2 is 8, so I got 8 here. 8 times 2 is 16, 16 times 2 is 32, and so on, until I've reached 128. Now that I have completed solving it, I will now bring it down. By the way, class, there is actually a simplified way of doing this. I'm just using tables here for you to be able to understand it clearly. Now, there's no problem on this part. I will simply copy this part here. So if you've noticed, they're actually the same set of digits. I just copy that here. After that, class, below it, I will copy the problem, or the binary numbers, or binary number that I need to convert. In this case, I will copy it as it is. So I will copy it from left to right. So if you've noticed, I've just copied this here. So I have 1 0 0 0 1 1 0 0. So now that I'm done copying it, this is just, I just put it here for it to be clear, but this is just the same as this one. So after putting that, I will now bring down the number. How do I know that I will bring down the number? You will only bring down the number if you see 1 with it, because 1 means on. So let's start. You can start either from right to left in this case, because it won't matter. Anyway, we will just bring down the value if it goes with 1. Say 128 with 1. Again, where did I get this value? This is the number, or the binary number that I'm trying to convert. 128 has 1, therefore I bring down 128. If it's 0, you will not bring down anything, you will just write 0. In the cases of 64, 32, and 16, it goes, or they go with 0. That's why I will just write 0 here. By the way, the ones in bold red are actually the answers. 8, 1. We have 1 here, therefore we bring down 8. Same with 4. For 2 and 1, you put 0 because again, they are paired with 0 in this case. So when you bring it down, you just add the numbers that you were able to bring down. I have here 128 plus 8 plus 4. If you add them, that is now equal to 140. Now class, where did I get the base 10? Again, you have to take note, or base 10. Again, you have to take note that I'm sorry class, I meant 10. You have to take note that for decimal numbers, the radix or base is 10. That's why whenever you convert a binary number to decimal number, you should always put radix 10. Never forget that. And that is, by the way, constant. Now, let's check out another problem. I have here convert 1 0 to decimal. By the way, how do I know that this is 1, 0 and not 10? Because I have here the radix 2. And we have to take note that binary digits has the radix or base 2. So let's now convert it. As I've said earlier, whenever we convert, we count how many digits does a binary number have. In this case, we have 1, 0. Let's count. 1, 2. Since I have 2, I will now put 2 number 2's. So I have here 1, 2. And as I've said earlier, the exponent always starts with 0. So I have here to the power of 0 and another one to the power of 1. Why is it 1? Because after 0, we have 1. Now, I will start solving it. 2 to the power of 0, or as what I've said earlier, the shortcut is that we always when we convert it, we always start with 1. Then we multiply by 2 to get the next digits. So I have here 1 times 2. That's why I got 2 here. Now I will just simply copy this part. 2 and 1. Then we bring down 1, 0, our binary number. So we have here 1, 0. So I just copy this on this part, then we will solve it. It is still the same. The ones highlighted in bold red are the answers. So you can either solve from left to right. It's up to you because it will not affect your answer. In this case, I have 2, then 1. Since it is paired with 1, it means it is on, so I will bring down 2. And in this case, 1 and 0, since my 1 here is paired with 0, I will not bring down anything. Instead, I will write 0. Now I will add them. 2 plus 0 is equal to 2. Therefore, my answer now is 2. Again, never forget base 10 because we are talking about a decimal number. I hope you're able to understand the positional notation. Now let's talk about the next method, which is doubling. This is way easier for me. I hope you find this easy too. These are the steps here, but I will give you my simplified steps. We will convert the same number and let's check if we can still get the same conversion, which is 140. So I just copied this here. This is just the same number. Again, we have base or radix 2 because this is constant for binary digits. How do we start? Always take note that whenever you use doubling, you always start with 0 times 2. Again, when you use doubling, you always start with 0 times 2. Where did I get 1? Okay, since I've already arranged that, for you to easily understand, I've matched their colors. When we start with 0 plus 2, or I mean 0 times 2, we add the first digit of the binary or the first digit of the binary number starting from the left. So, in this case, what is the first number from the left? We start here, which is 1. That's why I added 1. So 0 times 2 is 0. By the way, class, have you noticed that I've multiplied all of them by 2? Because 2 is the base of the binary digit. Again, we start with 0 times 2 and I will add 1. How do I know what to add? We always add the binary digits, but then we always start with the first number from the left. In this case, we have 1. So 0 times 2 is 0 plus 1 is 1. That's why we have 1 here. Now, how do we move on to the next stage? We simply copy the first result. In this case, it's 1. That's why I've copied 1 here. Now that I have 1 here, I multiply this by 2. Again, we always multiply by 2, which is the base of the binary digit. Then I will add the next number. I'm done using 1, so I will now go to the next number, which is 0. That's why I have added 0 here. 1 times 2 is 2 plus 0. Nothing changes. That is still 2. Now that I have 2, I will now bring down 2. I will still multiply it by 2. Then I will add the next binary digit, which is 0. So I have here 2 times 2, which is 4 plus 0, it's still 4. Now, I will bring down my answer 4. Then I will multiply it by 2 plus the next binary digit that I have not used from the left, which is 0. If you've noticed, they have the same color. Again, I intentionally did that for you to be able to trace it. 4 times 2 is 8 plus 0, it's still 8. Now that I got 8, I will bring down the result again. Then multiply it by 2, so that's 16. Where did I get 1? I will now get the unused number from the left, which is 1. So that's 8 times 2 is 16 plus 1, that's 17. Now I will bring down 17 times 2 again. Then I'll add the binary digit that I have not used. In this case, it's 1, so I added 1. 17 times 2 plus 1 is 35. Now I will bring down 35 again and multiply it by 2. Again, we always multiply it by 2 because 2 is the base of the binary digit. Then I will add 0, the unused 0 in this part, because I'm done using these numbers. So I will now use this 0, the pink one. So 35 times 2 plus 0 is 70. Now I bring down 70 times 2, then I will add the last 0 here. Now I got 140. But then again, since it is already in decimal, I will use the base or radix 10. That's why I have 140 radix 10. So when do I know that I should stop? You should stop if you have already used the last binary digit. If you've noticed, I've used the last 0 already, or I've added that, that is when I stop. Now, did we get the same result as earlier using positional notation? Yes, we did. When you solve from binary to decimal, you can use either of the methods that I've discussed, as long as you get the correct answer. Now, let's move on to conversion of decimal to binary. These are the steps, but don't worry, class. I will teach you the simplified steps in this discussion. But of course, you have to take note that in binary digits, the ones on the right or the last number on the right is called LSB, or least significant bit, while the ones or the last digit on the left, or should we say the first digit starting from the left, is the most significant bit. So let's check the example. This is how you convert decimal to binary, but this looks kind of complicated. Although you can do it this way, I've created a table for me to easily explain it to you. This is my table. So this time, we will convert 140 base 10 to binary. Again, do not confuse with the base 10 here, because you will simply add this to the decimal number, or you will simply put this at the end of your decimal number. Now, we have 140. Let's solve it. In solving it, we first start to write the decimal number that we are trying to convert. So in this case, we have 140. We always divide it by 2. Why do we divide it by 2 when we convert? Because again, the base of binary is 2. So let's say we have 140. 140 divided by 2. 140 divided by 2 is equal to 70. So you write the answer below it. And then, so what is this 0 for? This stands for the remainder. So you will have here 140 divided by 2, the answer is 70. Then you put the remainder beside 140. Now, let's divide the answer by 2 again. 70 divided by 2. Our answer is 35, so we write it down. Then we write the remainder on the right side of 70. That's why we have 0, because we have no remainder. Next is we divide 35 by 2. 35 divided by 2 is 17. You have to take note that when we solve decimal to binary, we don't put 0.5 or other points in there. Therefore, we count, say in this case, when we solve 35 divided by 2, we will count on how many 2 is in 35. Therefore, we have 17. Given that we have 17, we have remainder 1. That's why we've put 17 here, then the remainder 1 here. Now, let's divide 17, which is our result, by 2 again. 17 divided by 2, or how many 2 are there in 17? We have 8, but then we have remainder 1. So we put remainder 1 here. Now, let's solve 8 divided by 2. The answer is 4. Is there a remainder? There's none, so we put 0 here. Again, we put the 0 beside the number that we are trying to solve. Now we have 4 divided by 2. That's actually 2, so we write the answer 2. Then, there's no remainder, so we write 0 beside 4. Then now we have 2 divided by 2. The answer is 1. There is no remainder, so we put 0. Then we stop. When do we know when to stop? If our last result is 1 or 0, is either 1 or 0, that's the moment that we will stop. Now, how do I get my answer? So you will get your answers from the remainder, and you read it from bottom to top. In this case, the answer is 1, 0, 0, 0, 1, 1, 0, 0. Let's check. 1, 0, 0, 0, 1, 1, 0, 0. Again, do not forget base 2 if it's a binary number. So if you check that and you convert that, we actually got the correct answer. Now, I want you to try solving this on your own. First, you try to convert this decimal. By the way, is this a decimal or binary number? How do I know? You have to check first if it is 1, 0. But sometimes it gets kind of confusing because what if I write a decimal 10? So for us to determine if it's binary or decimal, we check the radix. In this case, we have a base or radix 10, therefore we know that it is decimal. Because if it's binary, we will have the base or radix 2. Now class, just choose 2 problems from here, then try to solve them. First, convert it from decimal to binary, and to check your answer, you can then convert binary to decimal. I hope you get the correct answer. And these are, by the way, my sources for this presentation. If you don't have, or if you have questions, you may email me. But I also encourage you to practice problem solving or converting decimal to binary and vice versa. I hope you're all learning. You have a good day. Thank you, class.